So I want to start by admitting that I feel very out of depth with this talk, like a non-swimmer, which is what I am, thrown overboard far out in the ocean. But I do want to have a frank conversation with all of you as fellow AI researchers. I hope that by sharing some of my own misunderstandings and mistakes, I can help you avoid some of them. So let's start by talking about preferences. Do you like eating out? I love eating out. But how do we choose which restaurant to go to? I consider factors like cost, decor, food quality, food type, neighborhood, and service. Each of us may value some of these factors more or less. For me, some of these are absolutes. For example, as a pescatarian, I am never going to want to eat at a barbecue joint. Generally, my dispositional preferences, that's my preferences over time, are stable. And with them, it's possible to calculate my values-based preference for any one restaurant over any other. A well-known method for collecting these dispositional preferences is the SMARTER method described by Edwards and Barron. And I invite you all to play along now. It goes like this. You are in the worst possible restaurant. The food is terrible. It's a kind you don't like. It's expensive when you can even get it because the wait staff are non-existent. It's in a terrible neighborhood that's very far from your house, and the decor is just abysmal. Now suddenly, a magical being appears and says, I can change one thing about this dining experience. What is the one thing that you would ask the magical being to change? Feel free to post your answer in the chat. Now for me, I would say if everything else is going to be terrible, at least it should be cheap. Now the way SMARTER goes, that magical being disappears and a slightly less magical being appears and says, I can change anything about this dining experience except the cost, the thing that I previously chose. And we play this game with increasingly less powerful magical beings until all my preferences have been elicited in strict order. Okay. And that's how we get those weights for that sort of regression looking model there. Of course, what matters to me may not matter to you. In a paper published in 2002, we collected eating out preferences from about 30 people using this SMARTER method and built a dialogue-based recommendation system for restaurants. We discovered that most people fall into one of two categories. Either they're cheapos like me. If everything is going to be terrible, at least it should be cheap. Or they're foodies. If everything else is going to be terrible, at least it should be good. But then there are some people who are unusual and have very strong preferences for food type or decor even. It's also important to point out that dispositional preferences may be overridden by situational constraints. For example, if I am taking my carnivore husband out for a special meal, perhaps I do go to a barbecue joint because that's what he would like. Or if I'm super hungry and on a long road trip, perhaps I do eat at Burger King, where I would not normally eat because I am pressured by the situation. I find this framework useful for thinking about many things. For example, maybe AI research is a little like dining out. The types of research that we do and the ways we do it are driven by our dispositional and situational preferences regarding research-related values. For example, many of us care a lot about accuracy. So this means we are more likely to work with supervised machine learning techniques than with unsupervised machine learning techniques. I've listed here a set of values that people use to describe their research, generally in the introduction or conclusion sections of their papers. I've tried to cluster them into three groups: type-related values, such as field and area, speech processing, natural language processing, computer vision, robotics, or quality-related values, such as accuracy, efficiency, and transparency that span many types of research, and cost-related values that generally pertain more to us as researchers and to our research processes than to the outcomes of the research itself. Take a minute and think about these values. Which ones did you prioritize in the research you are presenting today? And which ones do you want to prioritize in your career? Let me ask you, which values do you consider most important for an AI researcher to prioritize? Feel free to post them in the chat. Now consider, if I said to you, you are in the worst possible research environment. everything is bad. You have no funding, there is no data, or the data that you do have is bad. You have very old computers. I don't know, the people around you are awful. It's in a location you hate. And suddenly a magical being appears and says, I can change one thing about this research environment. What would you choose? And is your choice the same as when I asked you which values you consider important for an AI researcher to prioritize? It might be interesting to consider why you might have made the same choice now as a minute ago, or why not. Another way in which AI research is like eating out is that situational constraints may modify dispositional preferences. How this often works is that we have regular dispositional preferences regarding the type and the quality of the research that we do. For example, I like accuracy and generalizability, and I like to work with text and dialogue. But cost-related situational constraints, for example, I need to get into graduate school, I need to get a research job, I need to get tenure, I need funding for my students, modify those dispositional preferences. At this point, some of you are asking where the AI is in this talk. So let me back up a bit. I'm so excited by all the interesting research that you will present today. It represents a lot of hard work by you and your mentors and advisors, and I am really looking forward to seeing it. But first, I want to talk about how my understanding of AI has changed over time. This section is titled, I didn't realize people were involved. When I was just starting to learn about AI in high school, so I was younger than almost all of you, I think, AI was driven by logic-based methods. I learned about AI through proofs, believe it or not. I thought it was amazing that you could tell a computer some true things and some rules for inference, and it would then tell you many more true things. I still think this is amazing. I thought AI would be this fascinating way to do pure science, to understand not only, or even mainly, how humans think, but how thinking should happen. Leaving aside my intellectualism and all the values judgments inherent in that, of course, I was forgetting that AI is not just about computers. It's even more about humans. As my science, technology, and society or anthropology colleagues have told me, like any science, AI is a socio-technical construct. We all have things we want to discover or build, and ideas about how to do that, and things we think are more or less important to focus on as we do that, i.e. values. In other words, if AI is a truth factory, then it's a limited truth factory. It only tells the truth about the things that the people who build the AI care about, and it may only tell a partial truth, even about those things. So, in other words, the argument that I am making today is that the values, preferences, the dispositional and situational constraints that we have for AI research, both science and engineering, drive the nature of the AIs we develop, and the values trade-offs that we make for ourselves as researchers and practitioners are as impactful as the values preferences that we have for the science and the engineering. I'm going to illustrate this with 3 examples from my own career. Before I start, I want to emphasize that if you think the values trade-offs that were made were wrong, please blame me and not my collaborators. If you think they were right, the praise almost certainly goes to my collaborators. Or step aside from judging for a few minutes and just think about the values trade-offs each example illustrates. The first example is titled, I was in a hurry. Let's consider the puzzling case of the missing links. Back in 2013, a colleague and I participated in a natural language processing shared task about modeling the temporal ordering of events in text. This shared task had 3 parts. So you were given documents from general news. This happens to be a couple of sentences from a Slate article about the Olympics last week. And the first task was to identify the time expressions in the document. So here they're all years, 2008, 2010, 2018, 2022, but they could be things like yesterday or at 2 p.m., things like that, any kind of temporal expression. The second task was to identify the events in the document, typically verbs, but sometimes not verbs. So here we have placed, placed, continued, placing, and medalist. And the third task was to order those events in time. So here we have Evan Lesacek placed before, he placed in 2008, he placed before in 2010. And in 2010, he placed before now when that trend continues. And in 2018, Nathan Chen placed somehow. And then in 2022, he is now a medalist. Okay, so those were the three tasks. In the first task, we achieved the highest precision amongst all the competitors. For the second task, we achieved the highest F1 across all the competitors. And we did not submit to the third task. Why did we not submit to the third task? Well, we got really low accuracy. We got performance that was really bad about chance, and we were so puzzled. And the thing is, we were in a hurry because we had only decided to participate in the shared task maybe 3 weeks before the deadline. So we only had really minimally looked at our data. We assumed, because it came from the shared task, that it matched what we thought it would look like. Let's see if you can figure out what went wrong. Here are the labels for task 3. Before and after, includes and is included, holds, simultaneous, before, immediately after, identity, begins, begun by, ends, and ended by. Well, after the deadline, we looked at the data, and they had labeled correctly before here, and then they had not done the logical completion to after. So sometimes they labeled after, but not the logical completion to before, and sometimes they labeled before, but not the logical completion to after. In fact, in the paper, they talk about somebody's inference method. So a couple of teams who participated did actually look at the data and make the logical completion. And they did submit to that task. The thing is, if we had computed that closure-based inference, as they said, we would have won task 3. When we went back with the closure-based inference data and ran our method, we would have won. So what values were and were not driving us in that research? Well, accuracy was driving us. We really only wanted to submit if we were pretty sure we would win, because otherwise the company that we worked at would have looked bad because we were a big company and some of the participants in the shared task were very small universities. So we wanted success. We also needed to do the research in a hurry. So we were valuing expedience because the deadline was coming up. And what values were we deprioritizing in favor of those values that we were prioritizing? One of them was understanding. We thought we knew about temporal ordering. We didn't need to look at the data. We didn't need to understand this task in more detail. And another thing that we were deprioritizing was reproducibility, because we were just in a hurry. So it was research code and it was just put together in a hurry for the shared task. So I will say at this point that even those teams who did participate in all 3 shared tasks, a couple of those teams put out systems that are widely used by companies to extract time expressions from documents and even to do temporal ordering of events in documents. And this is a task that humans do fairly easily, but these systems are far from perfect. The data they are trained on and the rules they implement are for general readership news. And if you try to apply them to conversational data, which I have done, or to finance news, which I have done, they fall over completely because they literally do not have the capability from their training data or their rules to represent those types of temporal expressions or those types of ordering. So for the Slate News article, they'd be fine. But for Bloomberg News, no. And for dialogue systems, no. And of course, we all know that our ML systems are not perfect, but when we submit to a shared task or write a paper, we say we achieved state of the art. And sometimes people read that and think that means it works in general. Now, remember when I said that AI only tells the truth about the things the people who build the AI care about, and it may only tell a partial truth about even those things. Well, in the case of AI data, it gets worse. The time expression data is fairly innocuous, I believe. It's general purpose news articles. I doubt that anybody would die from a system that performed badly on those, but I don't know. But there are many data sets we now know that are widely used in AI that have really troublesome aspects to them. For example, they include private data that can be reconstructed from the model, or they include data that was collected without consent, or they include data that involves significant elements of bias, or they include data that is not safe for work and is really criminal in behavior. So it gets much worse. Backing away from my particular story, let's talk about AI in general. The open science movement has demanded public release of code and data, rightly, I think rightly, to increase understanding, transparency, and reproducibility, which are important values. But this has been subverted to the ends of speed and expedience, which may also be values that some people have, but I suspect that very often expedience is a value that we prioritize because of our situation, not our dispositional preferences. And this has come then at the cost, perversely, of the very understanding that the movement has as a goal, as well as at the cost of generalizability and security and safety. I'm not saying that in order to solve this problem, we should get rid of open data and open code. No, open code and open data may be necessary preconditions to transparency, understanding, and reproducibility. They may or they may not, right? There's a lot of research on differential privacy and querying data sets and things like that. But for now, practically speaking, they are necessary. However, they are not sufficient conditions for understanding, transparency, and reproducibility. It is really critical as AI researchers that we inspect, understand, document, and own our use of data, whether we created it or somebody else did. Okay, now let's turn to my second story, which illustrates how data issues in AI may be confounded by failures of imagination. This one is titled, "I Didn't Think It Was Possible." Let's examine the curious case of the pace of progress. Twice in my career, I have been asked to be involved in research on a certain type of AI application that I will broadly describe as simultaneous translation or simultaneous video translation. The first time in 2005, I thought it was crazy that the sponsor thought this could ever be a commercially viable or successful thing. But if those of you who were alive in 2005, you will understand why I thought that was crazy. But I thought it was an interesting thing to explore because it involved multiple modalities and reasoning about context. And I had a student who was interested and the student needed funding. So we built a proof of concept, which did not work very well because we didn't have the access to data, compute, and sophisticated neural networks that we do today. The second time in 2020, which is 15 years later, I was troubled by the work from the beginning. I thought the security risks were high, in particular about making deepfakes. However, there were lots of smart people around me who didn't seem worried, were interested in the project, and there were students who were interested in the project, and there was funding. So I suppressed my concerns, attended several product meetings from the perspective of a potential customer or user of this technology. By the time the student work on the second project was completed, it was very clear that there was both a foreseeable chance of successful deployment and a foreseeable chance of misuse of this developed technology. So in 2005, it was possible to work on, but there was no foreseeable chance of success, and so the stakes were low. In 2020, it was easier to work on, there was a foreseeable chance of success, and the stakes were high. And in both cases, I let certain values, for example, going along with the flow or encouraging student interest, overtake certain other values that I may have had. I still feel guilty about not speaking up more loudly and forcefully when the second project started to communicate my concerns, and I still wish that I had refused to be involved. The values that I prioritized in being involved, such as going along and potential commercial utility, are actually less important to me, a lot less important to me than my dispositional preferences related to AI safety and fairness. But I let the situation override those strongly held dispositional preferences, and I regret it. Of course, I'm not the only one to fail to foresee how quickly AI research can move to application. Let me give you an example. Roger Moore and colleagues collect every 6 years a survey of speech experts on when they think particular kinds of speech application will be widely available in production. In 2015, they asked speech experts when they thought the earliest date was that speech recognition would be commonly available in the home, and they guessed 2022. The Alexa was generally released in the USA that very same year, 2015, and by the end of 2017, there were more than 30 million of them sold. That same year in 2015, they asked speech experts when they thought voice-enabled command and control in cars would be common, and they guessed 2025. And since 2018, in the US, more than half of new cars have come with in-car speech recognition in English standard. So even experts, not just me, many experts suffer from failures of imagination. We make fewer failures of imagination than anyone else. Just like anyone else, we assume that history predicts the future, that current and future opportunities and risks will resemble the past. And we also often have blind spots when it comes to potential harms that don't immediately apply to us. And many of us as AI researchers inhabit positions of privilege. So from foundation to roof, the AI house is a fixer-upper. One of those things you see tremendous potential in, and you buy it, and you don't realize the amount of work that it's going to take to keep it up. The way AI research is done today makes it easy to unthinkingly develop that which will cause harm, and then claim no control over the use of what we developed. It is really critical to inspect, understand, and document your applications. We have a lot of really beautiful math in AI. It is a truth teller. There are extraordinary achievements and successes. Unfortunately, we also have a lot of really ugly practices in this fixer-upper, from data collected from workers who are not paid a living wage, to data collected, used, and reused without consent in production applications, to whole populations ignored in our research and development. We have advanced since the 1990s when I started, if you can call it that, from Lena the Playboy star in our computer vision models to upskirt photos, and from news data in our NLP models to hate speech. And we have never had representation of Black, Hispanic, and Indigenous populations in our data, our applications, or our labs. These are values-driven choices. We have repeatedly used expedience and precedent as puerile excuses for our failure to consider fairness and justice. How can this change? My third example is a happier example. This one is titled, I Listened to Other People. Let's talk about the fascinating case of the Inclusive Values-Driven Research Project. My colleagues on this project worked on text-to-speech synthesis, and the approaches that they were working on at the time were more natural than older ones. They were called concatenative speech synthesis, where they stitched together little bits of speech from actual human beings, whereas the older ones were called formant synthesis and were based on mathematical models of the human vocal tract. However, people who are blind communicated firm preferences for the older ones. We were interested in exploring this phenomenon and in developing an experimental method that could be reused by an international standards committee going forward to evaluate speech synthesizers. So we collected text-to-speech generated prompts from 4 systems, 2 older ones, formant-based, and 2 newer ones, concatenative. We then asked experimental participants to transcribe when they heard. They could listen to the prompt once, or maybe twice, I forget, and then they had to transcribe what they heard. And we recruited older and younger participants, as well as participants who were blind expert users of TTS and those who were sighted, non-expert users of TTS. And you can see here just many of our interesting findings. The accuracy goes down the faster the TTS is, but it goes down slower for the formant-based synthesizers because they can speed up more easily than the concatenative ones. And it goes down slower for people who are expert users of those synthesizers than for people who are not. And it goes down slower for younger people than for older people. So those findings were all very interesting, and I was really happy about both the way this research happened and what happened. This is a quote from our acknowledgement section at the end of that paper. We thank the standards board, who we worked with as stakeholders throughout. We thank the text-to-speech synthesizer scientists who generated their text-to-speech synthesis output. And we also acknowledge the experimental participants who not only worked with us, but many of the ones who were blind took time to send us detailed feedback on how the various speech synthesizers interacted with their screen readers. And that was really informative and useful. And I continue to be happy with how this research happened and what came of it. The values that were driving me, at least in this research, where I really wanted to understand how people of different types with more or less experience with these speech synthesizers deal with them getting so fast. And this came because I was in a meeting where there was a person who was blind and she was listening to her iPhone. At the time, the iPhone was relatively new and it was the first accessible phone. And the way the speech synthesis was on there was so fast. It was 8 times real time. I could not understand a word it was saying and she had no problem. 8 times real time, insane. So I really wanted to understand. And I also wanted to figure out how these synthesizers could be made more generalizable. And then there were a couple of values that sometimes I was concerned because the research took a long time to happen. There were many stakeholders and that slows things down. I wanted things to go faster, but we did not prioritize speed. We prioritized understanding, fairness, and generalizability instead. And I continue to be happy with how that research happened. It was fun, it was interesting. And then the later papers, which I was not involved with, are also really important and foundational results from different kinds of people. So that's an example of a project where I think the way the work was done and the outcomes were more in accordance with my dispositional preferences regarding scientific values than with any situational constraints. So I want to conclude with some suggestions for how we can have values discussions as researchers in AI. Although there is very rarely a clear cross-cultural right or wrong, and as someone who wanted a truth factory in high school, this makes me uncomfortable and it probably makes some of you uncomfortable. We should find ways to surface the values we are prioritizing and make the discussion explicit as part of doing AI research, because only when it's explicit as an object of study can we really understand or analyze it. There's plenty of interesting research to be done here, even if AI practitioners are more likely to be the research subjects than the actual researchers. And here I'm going to propose just 2 ideas. The first is that we should broaden the participation in conversation around values surrounding AI research and practice. We should involve AI researchers, users, product managers, lawyers, sociologists, philosophers, poets, artists, anthropologists, the person you meet at the grocery store, people who are blind, people who are deaf, people who are young, people who are old, everybody. And we should engage these stakeholders throughout the AI life cycle, not just at the beginning and not just at the end in an experimental study. We should learn to ask hypothetical questions. What if? What if this project were to take twice as long? What would be the worst thing that would happen? What if this project were to be done under certain other constraints? What would be the best thing that could happen? Just hypothetical questions. And we should listen to all these stakeholders throughout. This does necessarily slow the research project down because you have to learn to communicate in the same language, but I think it's a valuable practice. The other suggestion that I have is to lower the stakes on conversations about values. You know, anytime we say values, everyone goes, ooh, right, wrong, morals, ethics. That's why I started by talking about how we decide where to go out to eat, because we also are expressing values preferences then, but those values seem much more low stakes to us. So let's try to lower the stakes on conversations about values by adopting judgment-free postures, practicing active listening, making it a game, and being mindful. And I'll close with an example of how to make it a game. I had a group of students in a Jan plan course at Colby. This is an intensive course. The students didn't know each other, they didn't know me, I didn't know them, and of course I was going to give them a grade. And on the second day of class, before we knew everybody, we talked about values. And I brought index cards to class with values on them that are relevant to AI research, like some of the ones we've talked about: trust and trustworthiness, assurance, security, privacy, fairness, environmental justice, accuracy, generalizability. And everybody got a set of cards. So we distributed the cards amongst us equally. And then we all looked at our cards. And if we could keep 2 cards, so if each of us had 4 cards, we had to drop 2 on the floor that we thought were less important to us than the 2 we were keeping. And if you saw someone drop a card on the floor and you thought it was important, then you could pick it up, but you had to put down one of your cards. So then we ended up with half the cards that we started with. And then we laid out the cards that we had chosen on the floor and organized them. And then we did a further filtering. In this way, we lowered the stakes from your values are not the same as my values to just a general sort of game and a discussion of values in general, and less about what's right and wrong and more about choosing for this particular situation. We could have these kinds of conversations often. And if we feel the stress rising in us during the conversation, then we should stop, look, and listen to each other. I'm sure there's a lot more skilled techniques than these, but these are some of the ones that I have been trying to use. The stakes for AI are definitely high. What astonishes me is the speed of the current AI field and method collapse. The transformer architecture across computer vision, natural language processing, speech processing, recommender systems, has in 3 years become the state-of-the-art architecture. The architecture works for many areas of AI. It leads to simplicity and consistency and generalizability. It means that today, not just people are using the same architecture, but the same exact model trained on the same exact data across widely different AI applications. At the same time, transparency has decreased and understanding is no easier than ever because researchers and practitioners use these large models without investigating them, without understanding them, without considering questions of bias and fairness. These models work. They may lack explanatory power, as a scientist I grumble, blah, blah, but explanatory power may not be a value that matters to you. What should matter to all of us is that it is now surprisingly easy to develop and deploy new AI applications without thinking about things like generalizability, privacy, safety, security, and inclusivity. As the National Academy said back in 2017, the integrity of knowledge that emerges from research is based on individual and collective adherence to core values of objectivity, honesty, openness, fairness, accountability, and stewardship. And as a field, we have to continually examine ourselves as to whether these are values that we are willing to espouse, and if so, are we living up to them? I want to thank you for your time. I want to also thank the members of the Working Group on Responsible Computing Research with whom I have been working over the past 1.5 years, and the outsiders and insider outsiders whose papers I have cited throughout, who keep raising questions about values in AI research and forcing us all into a position of discomfort, which is where we need to be to learn. Thank you.